Welcome to Naradar Academy. In this video, we are going to discuss about classification of second order PDE, okay, and how to write its canonical form and how to find its characteristic equations. Okay. Now let's consider a second order linear partial differential equation AUXX plus BUXY plus CUYY plus DUX plus EUY plus FU equal to G. Here U is the dependent variable which depends on X and Y. Okay, U is a function of X and Y, and this denote dou square U by dou X square. This is dou square U by dou X dou Y. This is dou square U by dou Y square. This is dou U by dou X. This is dou U by dou Y, and this is U. Okay, so this is the given equation, and this A, B, C, D, E, F, G, they are all coefficients and they are all functions of X and Y. Okay, depending on the nature of the coefficients, we classify the equations as elliptic, parabolic or hyperbolic. See, this value B square minus 4AC is there, no? If it is less than 0, the equation is said to be of elliptic type. If B square minus 4AC equal to 0, it is parabolic. If B square minus 4AC is greater than 0, it is hyperbolic equation. So what here we are going to do is, here U is a function of xy, we are going to change the variable, right? I am going to introduce two variables, okay, psi and another one is eta, right? Psi is a function of xy and eta is also a function of xy, right? Whenever we change one variable into another variable, we have to check the Jacobian value. Only when the Jacobian is not equal to 0, the transformation will be a valid one. So here also, while doing this transformation, I am assuming the Jacobian is not equal to 0. Okay. So after making this, the given differential equation, partial differential equation is transformed like this. A bar of U psi psi plus B bar of U psi eta plus C bar U eta eta plus D bar U psi plus E bar U eta plus F bar U equal to G. Okay, this A bar, B bar, C bar are all we have to find using this formula. See, F bar is equal to F and G bar equal to G. See, G is function on the right hand side, that is without any U term is there, no, that is our G, and that is taken to be G bar, and F is the coefficient of U, no, so here also F bar is the coefficient of U. All other things will get reversed, right? A bar contains primarily the derivatives of first order derivatives of psi. Okay, so A bar equal to A psi x square plus B psi x psi y plus C psi y square. Similarly, C bar is primarily depending on eta, first order derivatives of eta. So similar to A bar, you have to write C bar. Here A psi x square, no, here it is A eta x square plus B, here it is psi x psi y, here it is eta x eta y, here C psi y square, here it is C eta y square. Okay, A bar and C bar are over, and B bar contains the combination of psi and eta. So it is written as 2A psi x eta x and 2C psi y eta y, and for B into psi x eta y plus psi y eta x. And D bar contains both second order derivatives and first order derivatives of psi alone. Okay, so for writing D bar, you write A, B, C, D, E, right? You have to start from psi xx, psi xy, psi yy, psi x, psi y. Okay, first all the second order derivatives should come and then psi x, psi y. Similar for E bar also, right? All A, B, C, D, E. So eta xx, eta xy, eta yy, eta x, eta y, right? So after writing this, we will get the canonical form. So the first step is you have to check whether the equation is elliptic or parabolic or hyperbolic. That is the classification. After that, here you have to do the transformation. After this transformation, you will have the characteristic equation, that I will write the characteristic equation while doing the problem. Okay, and after the characteristic equation, you have to write the canonical form, right? This is the order we are going to see in this video. So let us directly go to the problems. Reduce the following equations to canonical form and also solve it. Okay, so first step, identifying the equations type, right? Now look at this equation, 3uxx plus 10uxy plus 3uyy equal to 0, right? So A equal to ux's coefficient. So a equal to 3 and b equal to 10 and c equal to 3. All the remaining are 0 only, no? So d, e, f, g are all 0. Now you check what is the value of b square minus 4ac. It's equal to 100 minus 36 equal to 64, which is positive. So when the value is positive, it is hyperbolic type. Okay, once you find out the type, next you find out the roots of this equation. What is the roots of the equation? It is given by the formula minus b plus or minus root of b square minus 4ac, quadratic equation. For quadratic equation, this will give you the roots, no? So here, since the discriminant is positive, you will get two real and distinct roots. So first you find out the roots. The roots are minus 18 by 6 and minus 2 by 6, that is minus 3 and minus 1 by 3. After finding the roots, you have to write the characteristic equation. See, characteristic equation is nothing but dy by dx plus the first root. What is the first root? Minus 3. Minus 3 equal to 0. And the next characteristic equation is dy by dx minus 1 by 3 equal to 0. Okay. So whenever the equation is of hyperbolic type, you will get two distinct and real and distinct roots. So for the two real and distinct roots, you have to write the characteristic equation like this. Okay. After writing the characteristic equation, we are going to solve this one. So let me come back here. The first equation will become dy by dx equal to 3. The second one is dy by dx equal to 1 by 3. I am going to integrate this. Okay. So dy equal to 3 dx and dy equal to 1 by 3 dx. So y equal to, after integration, y equal to 3x plus c1, and here y equal to 1 by 3x plus c2. You take c1 equal to 3, y minus 3x, and c2 equal to y minus 1 by 3x. So these c1 and c2 are taken to be my psi and eta function. So psi equal to y minus 3x and eta is y minus 1 by 3x. Okay, right. So after writing this psi and eta, you find all its first and second order derivatives. So psi x is minus 3 and psi y is 1. So obviously all the second order derivatives will be 0. And here also eta x is minus 1 by 3 and eta y is 1. All the second order derivatives are 0. Now let me write the values, find the values for a bar, b bar, c bar. Okay, right. Now obviously my d bar, e bar and f bar or g bar will be 0, because here in the given question f and g are 0, no? So f bar and g bar are 0, and this e bar and d bar contain second order derivatives. So all the second order derivatives are 0 here. So you won't get anything, right? Now a bar equal to, what's the formula? A into a bar is written with the first order derivatives of psi, isn't it? So 3 into minus 3 square plus 10 into, what is this 3? A value, right? A value I have written here, no? A, B, C. With this A, B, C I am writing. A, B, C you put, then you write psi x square. Okay, here it is psi y square and here it is psi x into psi y, right? How will you write? Write A, B, C, right? Then here you write psi x square, here you write psi y square. In between, what you write? Psi x into psi y. Okay, the value is 0. Next let me write C bar, then I will go to B bar. C bar in the same thing. Write the coefficients A, B, C. Okay, next you write eta x square here, eta y square here, here eta x into eta y. Okay, this is also 0. Then for B bar, okay, it is 2 into, right? 2 into, what are the values of A, B, C here? A is 3 only, no? So 2 into 3 into here eta x is minus 3 into minus 1 by 3. So eta x into, psi x into eta x plus 10 into, what is this 10? B, that is B into, that is here A, B, C, the same thing, A, B, C value you have to write. Then after that, then you write the values of mixed derivatives, right? So if you write and simplify, the value is minus 64 by 3. So only for B bar we have the value. So the equation, how will you write the equation? A bar into, what will you write? A bar into psi xx, like that. In the previous page I have written, no, right? So what is the equation? We have to write A bar into u psi psi plus B bar into u psi eta. In that way you have to write. So here actually in the problem we have taken it like psi xx, psi yy, like that. So you have to write the canonical form. The canonical form here is 64 by 3 into u psi eta equal to 0. So u psi eta equal to 0 is the required canonical form. If you can proceed further, you can proceed, otherwise you can leave up to this. This is called the canonical form. Since the equation is in simplest form, I am integrating it. So the derivative equal to 0 means what? It is a constant function of psi and eta. So it will be a function of f of psi plus g of eta, and I am writing the values of psi and eta here. That's all. Okay, this is the solution. The next problem, x square into uxx minus 2xy into uxy plus y square into uyy equal to e power x. So here a equal to x square, b equal to minus 2xy, c equal to y square, and g equal to x. E and f terms are 0. Now the discriminant value b square minus 4ac is equal to 0. So it is of parabolic type. Now let me find the roots of this quadratic equation. Minus b plus or minus root of b square minus 4ac by 2a is equal to 2xy by 2x square. Right. The characteristic equation is dy by dx plus root of the equation equal to 0. So since this is parabolic, there will be only one root for this equation. So there is only one characteristic equation when you have a parabolic type. Right. So let us solve this equation. Dy by dx is equal to minus y by x, no? So 1 by dy equal to minus 1 by x dx. So if you integrate, you get log y plus log x equal to log c, otherwise xy equal to c1. So this is taken to be my psi, and eta you have to choose such that it is not parallel to psi. Okay, let me choose eta equal to y so that they won't be parallel to each other. Find the first order derivatives. Eta x equal, psi x is equal to y, and psi y equal to x, and psi double x equal to 0, and psi double y equal to 0. Right. Here eta x equal to 0 and eta y equal to 0. Now a bar equal to for a bar what will you do? Put a, b, c, and then here eta x square, here eta x eta y, here eta y square. And for writing c, write a, b, c. Okay, a, b, c, then you write what? Eta x square, here eta y square, here eta x eta y. Okay, then for b also you have to write, okay, what is the value for b? We have seen. Say, I will take the page. For writing b bar, you have to write 2a, b, 2c. Right. So 2a. So what is my 2a? 2 into x square. 2x square into 0 minus 2xy into y plus 2y square into x. So it is 0. So b bar equal to 0 and c bar equal to y square. And d bar equal to minus 2xy. For d bar, how will you write? A, b, c, d, e, all you have to write no. And you have to put all the second order derivatives. Here I am having the mixed derivative epsilon xy. So that is coming here in d bar. So d bar equal to minus 2xy, e bar, f bar are 0, and g bar equal to g equal to e power x. Okay. So if you write the equation, you will be getting it as y square into u. What is this? U eta minus 2xy into u psi is equal to e power psi by eta. Right. Understand? Okay. Next problem, uxx plus x square uyy equal to 0. So a is 1, b is 0, and c is x square. B square minus 4ac is minus 4x square. So less than 0. So it is of elliptic form. So the roots are given by minus b plus or minus root of b square minus 4ac by 2a. So equal to plus or minus ix. So when you have elliptic type, you will be getting complex conjugates. So the characteristic equations are given by dy by dx plus first root ix equal to 0. The another one is dy by dx minus ix equal to 0. So we have to solve these two equations. So here it is dy plus ix dx equal to 0. Here dy minus ix dx equal to 0. So if you integrate, y plus ix square by 2 equal to c1, y minus ix square by 2 equal to c2. So this is our psi and this is our eta. Okay, when you have elliptic type, you will get psi and eta as conjugate of each other, because you are having complex roots. No, complex roots always occur in pair. So if one root is like a plus ib, the other root will be like a minus ib only. So here for this particular case, you have to take alpha as the real part and beta as the imaginary part. So that is given by psi plus eta by 2, and beta is psi minus eta by 2i. This is nothing but alpha is the real part and beta is the imaginary part. Without sign, you take the imaginary part. Okay, directly you can take here, or you can substitute in this formula. Right. So alpha equal to y and beta equal to x square by 2. Here for elliptic problem, you will be having in terms of alpha beta only. Okay, not in terms of psi and eta. So here alpha x equal to 0 and alpha y equal to 1. Here beta x equal to x and beta double x equal to 1. Beta y equal to 0, right? Okay, so now the canonical equations are given by, see, now let's find a bar, the same formula only. So a bar equal to, after substituting the values, I am getting a bar equal to x square, b bar equal to 0, c bar equal to x square, d bar equal to 0 and e bar equal to 1. So if you substitute, I am getting the equation as x square u alpha alpha plus x square u beta beta plus u beta equal to 0. Okay, that's all. Then last problem, y square into uxx minus 2xy into uxy plus x square into uyy equal to y square by x ux plus x square by y into uy. Okay, bring all the terms to the left hand side and you identify a, b, c, d, e, f, g. Right? After that, check the sign of b square minus 4ac. It is 0, so it is parabolic. Parabolic means you will be having only one root. So the root is given by minus b by 2a, that is x by y. So the characteristic equation is dy by dx plus lambda, that is lambda is nothing but this root, plus x by y equal to 0. So if you solve this equation, you are getting it as x square plus y square equal to c1. So this is taken to be my psi. Psi is equal to x square plus y square, and eta has to be chosen such that it is not parallel to psi. Okay, so let me choose eta equal to y square. Then find all the first and second order derivatives for both psi and eta and substitute in the values of a bar, b bar, etc. and write the canonical form as 4x square y square u eta eta equal to 0. That implies u eta eta equal to 0. This is called the canonical form. Since it is in the simplest form, I am going to simplify and find the solution for this equation. U double eta equal to 0, no? So if you integrate it first time, it will be u eta equal to f of psi. That implies u equal to eta f of psi plus g of psi, right? Otherwise, u equal to y square f of x square plus y square plus g of x square plus y square. Okay, that's all. Thank you.